I'm using Sklearn's RepeatedKFold for cross-validation on a dataset with 15 samples. I've set the number of splits to 3 and the number of repeats to 2. This question asks what is true about the resulting cross-validation folds. This tells us the size of the dataset we're working with, 15 samples. Here's where we define our cross-validation strategy. RepeatedKFold means we'll do 3-fold cross-validation, and we'll repeat the whole process 2 times. Sets the number of folds in each round, and sets how many times we repeat the entire 3-fold process. This is the core of the problem. We need to determine which statements about the result of our RepeatedKFold process are accurate. This highlights the main concept. We're dealing with RepeatedKFold cross-validation. That means we're going to split the data multiple times and then repeat the splitting process, creating multiple sets of training and testing data. This statement says that each data sample will show up in about the same number of testing sets across all the repeated folds. That's a goal of RepeatedKFold. Even distribution. This statement claims that we'll use the exact same training and testing sets each time we repeat the process. That's incorrect. This states that we'll end up with 6 folds in total. We can check this. The number of folds is 3 folds. Repeat * 2 repeats equals 6 folds. So this is true. This says that the folds will change each time we run the RepeatedKFold function. This is false. The folds remain consistent for each run with the same parameters. This is the final answer to how many folds I will get from my RepeatedKFold setup, 6. I'm using RepeatedKFold, a technique in Sklearn that does K-fold cross-validation multiple times. It's a really useful tool for getting more robust estimates of model performance. Think of it like this. You're evaluating a recipe. RepeatedKFold lets you bake it several times. Repeats. With slightly different batches of ingredients, splits, to see how consistent your results are. This question tests my understanding of how RepeatedKFold works, specifically with the number of splits, n_splits, and repetitions, n_repeats. It's all about figuring out how many different ways we test our model and how the data gets split into training and testing sets. This means I'm dividing my data into 3 different groups for training and testing. Each group will take a turn being the testing group, while the others are used for training. This tells me that I'm going to repeat the entire process of creating those 3 groups and running the tests twice. This gives me more confidence that my model's performance is stable and not just a fluke from a single run. This is the total amount of data I have to work with. I need to split this data up using n_splits and n_repeats ensuring every part gets a fair chance in both training and testing sets. RepeatedKFold is a Sklearn technique I use for cross-validation. It's like doing regular K-fold cross-validation, but I repeat the whole process multiple times to get a more reliable estimate of my model's performance. Think of it as doing the experiment again and again to see if the results are consistent. I calculate the total number of folds by multiplying the number of splits, 3, by the number of repeats, 2. That's 3 times 2 equals 6 folds. Each fold is a separate training and testing dataset. With RepeatedKFold, I aim for a balanced distribution of each data point across the testing sets in each repeat. This makes sure I get a fair assessment of my model's performance and that no single data point unfairly influences the results. I'm trying to avoid bias, you see? This is incorrect. RepeatedKFold does not change the splits across repeats. The splits are deterministic. The data is consistently split the same way each time the process is repeated. This is false. RepeatedKFold is deterministic, meaning the output is predictable and repeatable for the same parameters. There's no randomization involved in generating the folds in the same execution. We're using Sklearn's RepeatedKFold, a tool that helps us evaluate machine learning models. It's a clever way to do RepeatedKFold cross-validation. This means we divide our data into K parts, use parts to train a model, and then test it on the remaining part. Then, I repeat this whole process multiple times, improving the accuracy of the model evaluation. This tells RepeatedKFold to split the data into 3 parts, folds, for each repetition. We use 2 of the parts to train and 1 part to test. This means I'll repeat that 3-part split process 2 times. I have a dataset with 15 samples, data points, to work with. That's right. Because I'm doing 3 splits and repeating twice, I get a total of 3 times 2 equals 6 folds. RepeatedKFold aims for a fair division of data points. Each sample will appear approximately the same number of times in the testing sets across the repetitions. The idea is that your model gets fairly tested with each data point. Nope, that's not quite right. I reuse the same data splits for each repetition to ensure consistency and better evaluation. I don't randomly shuffle the data between repeats. No, RepeatedKFold is deterministic. Given the same settings, I will always get the same folds. There is no randomness involved within a single run. This phrase sets the stage. We're using a specific scikit-learn tool, RepeatedKFold, for cross-validation. We have a dataset with 15 samples, meaning 15 individual data points to work with. Cross-validation is a technique I use to evaluate how well a machine learning model generalizes to new, unseen data. It's like testing your model's performance on multiple different exam versions to ensure it truly understands the material and isn't just memorizing a single version. This introduces the core problem: determining which statements about the results of our cross-validation process are correct. This is our quiz, essentially. We'll need to carefully consider the implications of using RepeatedKFold with the specified parameters. This statement proposes that our procedure will produce 6 separate sets of training and testing data. I'll need to verify whether this is accurate based on how RepeatedKFold operates given the parameters. This hypothesis suggests that each of my 15 data points will be in roughly the same number of testing sets, for fairness and better model evaluation. I'll check if RepeatedKFold aims for this balanced distribution. This is about whether the RepeatedKFold keeps the same splits each time it runs. I need to determine if RepeatedKFold repeats the exact same folds. Here, the statement asks whether the results change each time I run RepeatedKFold. It also highlights the possibility of inherent randomness in the process. I'll need to understand if such randomness is actually involved. This reminds us that our entire dataset consists of only 15 samples. This is a small dataset. This fact will influence how I interpret the results of the cross-validation. I'm using RepeatedKFold, a scikit-learn tool for cross-validation. It's a powerful technique to evaluate machine learning models reliably. This means I'll split my data into 3 folds for each round of cross-validation. Think of it like dividing a cake into 3 slices. I'm repeating this 3-slice cake division process twice. This helps improve the robustness of my model evaluation. This is the name of the scikit-learn function I'm using for this repeated cross-validation. It's important to understand that it uses the same splits, but repeats the process, which is different than randomly shuffling the data each time. I get 6 folds total because I have 3 folds per repeat, and I'm repeating the process twice. 3 folds. Repeat *2 repeats equals 6 folds. Hey there, we are using RepeatedKFold from scikit-learn, a really useful function for robust model evaluation. It's all about cross-validation, a technique to test your model's performance on different subsets of your data. This minimizes overfitting, which is a big problem in machine learning. That's a key advantage of RepeatedKFold. I strive for a balanced representation of each sample across all test sets. This is important for unbiased evaluation. That's the FALSE statement. RepeatedKFold ensures each repeat uses the same data splits for training and testing. It doesn't shuffle the data, which is important for consistent model evaluation. That's incorrect too. RepeatedKFold is deterministic. The data splitting is the same every time you run it with identical parameters, so you get consistent results. That's absolutely correct. I'm getting 6 folds, because I'm doing 3 splits repeated 2 times. 3 times 2 equals 6. I'm working with a dataset containing 15 samples. That's the data I'm splitting and using for cross-validation. I'm using RepeatedKFold, a technique in scikit-learn for doing cross-validation. It's like repeatedly testing your model's performance with different subsets of your data to get a more reliable estimate of how well it'll generalize. It's a more robust way to validate a model than a single trained test split. This question tests how well you understand RepeatedKFold and how its parameters affect the cross-validation process. We'll be looking at how many folds, subsets of data, get created and how the data samples are distributed across those folds. I'm setting up RepeatedKFold with 3 splits. Imagine slicing my data into 3 groups for training and testing. And then I'm repeating this whole process 2 times. This repetition helps assess the stability of the model's performance across different data splits. It's like doing the experiment twice to check if I get similar results. Because I have 3 splits and 2 repeats, 3 times 2 equals 6. I end up with a total of 6 different folds. Each fold represents a specific training testing split of my data. I have 15 data samples. These are the individual pieces of information I'll be using for training and testing my model. This statement is true. As I explained, 3 splits multiplied by 2 repeats gives me 6 different sets of training and testing data for model validation. This is also true. RepeatedKFold aims for a balanced distribution. Each sample will appear in roughly an equal number of testing sets, which makes the evaluation more fair and unbiased. This is false. RepeatedKFold uses the same splits in each repetition, not different ones. This is false. RepeatedKFold does not use randomization. I'll get the same results each time I run it with the same settings. The process is deterministic.